we can, okay, so, okay. How high above 0.26? Well, the height is the value of f of x of f of xy when xy is 2,6. You plug in 2,6 into your function, which I've corrected. I had a minus z here, and that's not a function of xy, so I wrote that carelessly. So z is this, and if xy is 2,6, we're going to be at height 0.52 above the xy plane. Okay, well, let's just assume that point 1 and point 2 are small enough that the value of the function at this corner, or this corner, or this corner, or this corner doesn't vary much from 0.52. Now you'd actually very easily do a differential approximation and figure out how much this thing varies, and we're going to do that, but we're not going to do it just yet. Okay? So the region above this thing is it's a polytope, or it could be well approximated by a polytope, but if these numbers are small, whatever the slope of the polytope in the y direction is, it's not going to have much time to change the value of z. You've only got 2/10 of a unit to move here. And we could actually estimate, I'm tempted to do it, but I'm not going to, too much of a digression. Okay, and in 0.1 unit, whatever the slope is in the x direction is not going to have much time to change the actual value of z, so that we can do a good approximation of the region below the graph of the paraboloid and above this tiny square by just forming a rectangle, and a rectangular solid, okay? Meaning that we could come over here and over here and here and here, and now we've got a rectangular solid. It's a polytope, but it's not the most accurate polytope we could draw, because actually we would have a little slope. We'd have a slope here and a slope here. But the dimensions of this rectangular solid, this approximation of our polytope for this region, would give you a volume that's pretty close to the volume of the surface above this little rectangle. Now remember, this little rectangle is in the vicinity of this point. You know, on our original graph, that point might be about here in the xy plane, so it would be coming up to the graph here. Okay. We've taken this point, we've taken this segment of the x equals 2 line, we've expanded it to a little bit of width, we've taken the y equals 6 line, and we've expanded it to a little bit of width to describe this rectangle that we now see in the plane, and we know now what its dimensions are. So, what is the volume What's the volume of this rectangular solid? So figure that out. You should be able to figure it out in your head, but you might get messed up with the decimal places.